So the last chapter is all about sequences. It's about series. What does that mean? A sequence is a list of numbers that has a certain pattern. So 7, 11, 15, 19. I want to kind of show you the difference in just the basic idea. Let me move this out of the way. If I gave you y equals 3x plus 1, and I asked you to graph it, you go up 1, up 3, right 1, forever and ever. It could be any number in the whole wide world. But if I give you the number, let's see, 4, 7, 10, 13, that's a list of numbers where this is the first term, 4, second term, 7, third term, 10, fourth term, 13. So this is a continuous graph where any value could be true. But this is a list of numbers. It's discrete. It means this is the first value. There's nothing. There's no half value. There's also no real zero value. But what you're going to do is still have to create a function from it, and this would be called an arithmetic function. And you would write it like this, knowing that this is the zero term and this is the pattern. You will also learn to write it like this. Make that an A, actually. A sub n minus 1 plus 3. And A sub 1 equals 4. So you're also going to learn about two different types of functions. You're going to learn about an explicit function, which I have right here, an explicit sequence. Okay? You can find any term in the sequence. You want the 33rd term? Just put in 33, you can get it. You want the negative 33 term? Great, you can get it. But there's also something called a recursive sequence, which I have right here. And this means you need the previous term to get the next term. So I can't just get the 33rd term. I have to use the term that they give me, and now I would take that, plug that in, and I can go, hey, the next term is 7. So I would know the first term is 4. The second term, oops, let me move this up. The second term is 7. How would I get the third term? I would have to take the second term, plug that in, and get the third term. Oops, I can add. And then how would I get that term? Take that, plug it in, and so on and so forth. So we're going to start off by just finding terms and sequences based on the formulas. So the first thing we're going to have to decide is it explicit or is it recursive? Let me remind you again. Explicit means I can find any number in the sequence. I can plug in 1, 2, 10, 53, 96. So this is explicit. Let me put an E for explicit in pink. And I'm going to ask you to find the first 5 terms. Of course, I'm going to have you show work. So 1, 2, 3, 4, 5. I like existing in boxes and rows. It's easier for me to find things. So what I'm going to be doing is I'm going to be taking all of these and plugging them in. So I'm going to go 1 squared plus 3, 2 squared plus 3, 3 squared plus 3, 4 squared plus 3, 5 squared plus 3. And then I simplify. 1 squared is 1, plus 3 is 4. 2 squared is 4, plus 3 is 7. 3 squared, 9, 12, 19, and 28. So the first 5 terms in this sequence is this. And it is an explicit sequence. I can find any number. This one's also an explicit sequence. You want the 53rd number? Great. You want the 10th number? Great. So I write it out. And now this time, not only do I have one n, but I have 2 n's. So I'm going to go 2 to the first plus 1. 2 squared plus 2. 2 cubed plus 3. 2 to the fourth plus 4. 2 to the fifth, oops, plus 5. I'm trying to go fast here because I think you get the game. So that would be 3, 6, 11, plus 3 plus 5 plus 7 plus 9. Oh my gosh. Okay, so the first 5 terms in the sequence, 3, 6, 11, 18, 27. And by the way, I want to show you a pattern because I can't help myself. These are both, let me make sure I did that. Ooh, actually I did it wrong. Sorry, I was thinking it was a different pattern. That's 20, and that's, let's see, 32. Sorry, I was subtracting 37. So let's make that 20 and that 37. Let's see, the rest look good. Okay. So now let's go to the next one. The next one is a recursive sequence. I know things are recursive when I see this, a sub n minus 1. What does n minus 1 mean? The previous term. If I am, let me get a piece of paper here. If I am 40 years old, 1 year ago, I was 39. I'm older than 40. But that means that I take my value and I subtract 1. So if I take the previous one, then I can get the next one. So what does that mean I'm going to do? That means I'm going to take this 5, and it's going to go right in there. So 1, 2, 3, 4, 5. So in the previous problems, normally I've had to do work, right? To get the first term, I plug in 1. To get the second term. Here, they said, hey, you don't need to do any work. I told you the first term. But in order to get the second term, you're going to have to take that first term and plug it into a sub n minus 1. So it's 5 plus 4. It's saying take the previous term. You want the second guy? Take the first guy and add 4 to it. And then now they say, hey, you want the third guy? You got to talk to the second one and plug it in. You want the fourth one? Okay, you got to go to that third guy. And then so on and so forth. So the first 5 terms of the sequence are 5, 9, 13, 17, 21. You could actually create an explicit equation from this recursive one by going a sub n equals, hold on one second. So by doing, how do you find an equation of a linear sequence? You do the pattern and the 0 term. Because if this is the first term, and you're adding 4, you're adding 4, you're adding 4, if you subtract 4, that would be the explicit sequence, and that is the recursive. Just a different way to explain things. Okay? All right, let's look at the next one. In the next problem we see, a sub n minus 1. So that means it is a recursive sequence. So I'm going to go 1, 2, 3, 4, 5. And you don't have to do it exactly this way, but it keeps it organized for me. It's easy to find the work, and we're good to go. So what they're saying is, hey, you don't have to do work for the first guy. I told you the first one. It's -6. But then the second term says, okay, you want the second term? You got to go to the first term, and every time you see an a sub n minus 1, you have to plug in -6. -24 plus 6 is -18. Okay? You want the third one? Well, then you got to go to the second one, and every time you see an a sub n minus 1, you got to plug that in. You want the fourth one? You got to take the third one, and plug it in. And hopefully I'm doing this math right. Okay. And then you want the fifth one, and some of you go, wow, how are you getting the answer so fast? Well, I know that I noticed that the pattern was times 3 times 3. So then I'm just going times 3 to get the answer, and this one's not as easy for me to do, 486. So the first 5 terms in the sequence. Okay. That's a recursive. I could actually find an explicit by going a sub n equals, what's the pattern? Times 3. And then I need the 0 term. So the 0 term would be -2. Because if this is times 3 times 3, this would be divided by 3. Okay? And we're going to get into more about creating that, but I just want to put that in your mind. All right, let's look at this one. What do you think this one is? An explicit. What does an explicit sequence says? Say you want the 5th term? Great. You want the 10th term? Great. You want any term? You can just get the answer by plugging that number in. I'm going to pause it real quick and fill it in. I think I'm going to pause it there. So I want to show you, I took the ones. Every time I saw an n, I plugged it in. There we go. There we go. I also took at it as a different way as I distributed and got that. It's a quadratic. I then took the equation and I put it into Desmos, and if you look, there's all the terms in the sequence. Okay, let's do the last one. Is this recursive or explicit? It's an explicit equation. The only way is if you see a sub n minus 1, not a to the power. If it's to a power, then it is a function and you can figure it out. I'm going to plug it in and we'll get started. So I wanted to deal with this one because it's a fraction. It's actually 1/2 to the negative 2. Remember that when you have a negative, it means you flip it. So it's really 2 squared, which is 4. This is really 1/2 to the negative 1. Flip it. 2 to the first is 2. 1/2 to the 0. Anything to the 0 is 1. Hey, what is the pattern? Divide by 2, divide by 2, divide by 2, or multiply by 1/2. So that would be 1/2. A half times a half is a fourth. So 4, 2, 1, 1/2, 1/4. Okay. All right. Let's see. Oh, I can actually create, which I want to show you. I can't help myself. A recursive sequence from this one. So if I was to do a recursive for this one, I would say a sub n equals a sub n minus 1. What am I doing every time? Multiplying by 1/2. But you have to make sure you tell them the first term or any term so that you know where to start. Okay. All right, find the pattern and the next number. So when I look here, this looks like plus 9 plus 9. So that would be 44 would be the next number. And then I can find an equation. If it's a plus equation, an addition equation, you're going to learn that that is linear. So you do the pattern and you do the 0 term. Well, if this way is plus 9, then this way is minus 9. That means the 0 term is negative 1. Okay. This is a harder pattern here. Okay. And this one is plus 3, plus 5, plus 7, plus 9. So plus 11, 38. This is actually a quadratic function, but you're not necessarily going to have to know that, but you know it because plus 2, plus 2, plus 2. It took 2 layers to get a consistent pattern, so I knew it was n squared. If this is considered the first term, 1 squared is 1, plus 2 is 3. Look at the second term. 2 squared is 4, plus 2 is 6. So that is a quadratic function. All right. Let's look here. This stayed the same. So this is like times 1, times 1, times 1. And this is times 2, times 2, times 2. So sometimes when I see a fraction, I take it separately. I see what's happening in the numerator, what's happening in the denominator. So that means 3 times 1 is 3. 16 times 2 is 32. I can get the explicit equation by going, hey, the pattern is 1/2. This is exponential. We've worked on this. What's the 0 term? So if this way is times 1/2, then this way is divided by 1/2. So I would go 3/2 divided by 1/2, which is 3/2 times 2 over 1, which is 3. So my 0 term is 3. And I think that's it.